Okay, let's run the chi-square goodness of fit test. This is the same example that you read about in the chapter or will read about if you're watching the video first. But we're going to walk through all of those steps in Jamovi in a video instead of just reading it. So goodness of fit is testing whether the actual frequencies of a categorical variable match the expected frequencies of that variable. So in this case, we're going to use a data set called choice 1. So let's go ahead and open that up. So we're going to use the data library. You should have the LSJ data package module installed from over here. And we are going to open the choice, and we could just search. Oh, it's not liking that. Where are you? Oh, sorry, it's called randomness. There we go. Randomness. There we go. Okay. So in this example, we have how many subjects? Oh, we got a lot of subjects. 200 people. I know that because there's 200 rows and there should be a person per row. And then I have what they pulled from the deck the first time and what they pulled from the deck the second time. We're just going to focus on choice 1 for now. We want to see, is there an even pull from the deck? So a deck of cards tends to have, typically a deck of cards has 4 suits, right? We have hearts, spades, clubs, and diamonds. And we want to see if there's an equal probability, which there should be. There should be 13 from each suit. So it should be a 25% probability of each one. So our first step is always, hopefully this ingrains upon yourself throughout the semester. Always the first step is to look at your data. So we've just started that already. We've looked at our data setup. We've got the choices here. We can look at some descriptive statistics. So I'm going to pull choice 1 over. And notice that it doesn't give us our mean, median, and so on because it knows that it's a categorical variable, a nominal variable specifically. And so it shouldn't give us any of these descriptive statistics. So we'll actually want to select frequency tables, and we're looking at all of this and see that, looks like hearts is being pulled pretty more often than we'd expect and clubs not as much. Is that statistically significant though? That's what the goodness of fit test will tell us. So we've described our data. We could also ask for a plot like the histogram plot, a bar plot. Right? Histogram would be for a continuous variable. We want a bar plot. And so we see that we would expect it to be about 25%. It's not, so that's a little concerning. Let's find out what happens. The goodness of fit test has just one assumption, that the expected frequencies are sufficiently large, in this case around at least 5. So we'll test that looking at, we'll have to perform the test first to figure that out. So to do that, we go to frequencies and we go to N outcomes goodness of fit. We are just looking at choice 1. So we put that here. You'll see what this does later. We'll talk about that later in a subsequent assignment. We want to see the expected counts first. So this is to help us test that assumption of the expected frequencies. Expected is 50 across the board because there's 200 people, 25% each. That's in equal proportions in each expected frequency. And so that's 50 each. That is much bigger than our assumption that they are sufficiently large, greater than 5, right? So we are good. We've met our one and only assumption for the chi-square test. A little side caveat, I'm not sure if it's in the textbook, but the goodness of fit, the chi-square test in general, they are all non-parametric statistics. That's why we don't have any assumptions about normality, because we're working with categorical data. Categorical data can't be normally distributed, and so technically it's a non-parametric statistic. Okay, so we've got that there. We've asked for expected counts. We've checked our assumption. We are good to go. And now we need to interpret our results. And so we look at here. This is our chi-square test. We get a chi-square statistic, which is 8.44. Degrees of freedom is 3. It is the total number, in this case, the total n divided by the total number of groups. So it's 200 divided by 4. That is to get us our expected frequencies. This is the number of categories minus 1. Degrees of freedom is 3. 4 categories, clubs, diamonds, hearts, spades, -1 is 3 degrees of freedom. Our p-value is 0.038. That is less than our typical alpha of 0.05. Again, we'll use that default alpha of 0.05 throughout this class, but you should always think critically about what alpha you want to set for your statistic. Do you want to make sure, really make sure that you're not making a type 1 error, in which case you would lower your alpha to perhaps 0.01. And then if that were the case, we'd say this is not statistically significant. So in this case, we're just going to use 0.05. Our p is less than our alpha, therefore it's statistically significant, and we reject the null hypothesis, meaning that our observed frequencies are different from our expected frequencies. And to find out where those differences are, we can just look at our proportions table and find out that we tend to get, we're observing more hearts than we would expect and observing fewer clubs than we would expect. But we're pretty even on diamonds and spades. So I had an example write-up. I'm going to put that up here. So we can write it up something like this. Of the 200 participants in the experiment, 64 selected hearts for their first choice. I don't know why there's a little arrow, not sure. 51 selected diamonds, 50 selected spades, and 35 selected clubs. A chi-square goodness of fit test was conducted to test whether the choice probabilities were identical for all 4 suits. So that would be our null hypothesis. The results were statistically significant. I chose to put this within a parentheses, so that's an example there, comma, suggesting that people did not select suits purely at random. Maybe because people can choose the suit they want, or maybe there's something going on in their head. Probably not. More likely is that we have a loaded deck, right? And then we can visualize the results. I chose to actually do something in Excel and did it by expected proportions, which is that black line, and the observed proportions by suit, which are the gray bars. So rather than choosing this, which is the counts, and it won't add that expected lines, I did this all in Excel and did it this way. You can do something similar with this tutorial. Okay, and then real quick, maybe we had an idea that maybe our deck was loaded. We can change that using the expected proportions in the goodness of fit test. So right now, the default is that the proportions are balanced between them all, that there's equal proportions of clubs, diamonds, hearts, spades. Maybe I have this hypothesis that my hearts are actually overcompensated and my clubs is under. So we'll do that. We'll try that. And then it'll automatically change all this. And now we find if we had this hypothesis, the null hypothesis that this was the loaded deck, and we wanted to see if our data matches that null hypothesis of this loaded deck, we would find that we would fail to reject the null hypothesis that, yeah, it does seem to be that there is a loaded deck as we predicted. And notice how the expected frequencies now change based on the ratio that we provided. So if for whatever reason your expected proportions is not equal of a ratio across the groups, then you can always change it in Jamovi. And I think that's about it. You've got some opportunities to try your own examples, to try some more and give the answers. There is an answer key at the back of the textbook. If you go in here, answer keys, you can always test them out. So you've got plenty of opportunities to try the goodness of fit test before your assignment.